These problems are the last three problems you'll see for the test for Algebra B, Test 2, Quarter 3. So let's take a look at this first one here. It's talking about tickets to a movie were sold at $6 for adults, $4.50 for students. And so it says if 580 tickets were sold for a total of $2,970, how many students? Oh, here's the question. This is an important thing. This tells us where our variables go. How many students and tickets were sold, and how many adult tickets were sold. Okay, so let's do this. Let's call A the number of adult tickets. And let's call, instead of S, let's go with C for the number of students, because an S might end up looking like a 5. So let's do C equals the number of student tickets. And what we're going to end up doing is writing a system of equations. So the way I like to do this, or I like to think about these types of problems, is I think of a quantity. So we've got one as a quantity, we've got a quantity equation, and then we're going to end up with a value equation. So we're going to have two different equations here. So let's do the quantity first. Quantity is the number of tickets that were sold. So we have A adult tickets plus C student tickets equals the total tickets sold, which was $580, or 580 tickets. Now the dollar amount comes in. That's the value. And so what we're going to do is we're going to take the value of an adult ticket. So let's look up here. It says that $6 was the cost of an adult ticket. So let's go $6 times the number of adult tickets plus, and now $4.50 for the student tickets. So 4.5 times the number of student tickets sold equals the total amount. Oh, right there, $2,970. So let's go ahead and try solving this one. And I like to go ahead and get rid of these decimals, and so I'll go ahead and try that first. And so I'm going to multiply this bottom equation by 10. And what that'll do is it'll move that decimal over one space, but I'll have to deal with some bigger numbers. Now I want to cancel out maybe the a's first. It might be easier to multiply 60 than by 45, so I'm going to do that. I'm going to multiply this top equation by negative 60. And so I go ahead and do that, and let's see what I've got here. So it's going to be a negative 60a minus, gotta get that a in there, minus 60c, and this all equals, and then that ends up equaling negative 34,700, or negative 34,800. That's what we end up getting there. And then over for the value equation, when I multiply the 10 by each of these terms, I end up moving that decimal over. So it becomes 60a plus 45c, so now I don't have to deal with the decimal, equals, and then here I just add the decimals, or add that 0, so 29,700. And so I go ahead and add these together, and you'll see how the a's will end up canceling. Over here in the c's, I end up with a negative 15c equals negative 5,100. So from that point, just need to divide by negative 15, and I see the negative signs will cancel. And I see 15 goes into 51, goes in there 3 times with 6 left over. I'll bring down that 0, and 15 goes into 64 times with the extra 0 there, so that'd be 340 students that ended up showing up. Well, how many adults? Well, we just need to subtract that from the total. So I'll do some substitution here, put that 340 back up in here into this quantity equation right there, and for C, let's see what we come up with. So we have A, so A plus 340 equals, and then we have that 580. And so now we just do that subtraction and we'll have our answer. So subtract the 340 from both sides, and it looks like we're going to end up with 240 adults. So a whole lot more students went than adults in this case. Well, let's take a look at the next problem here. And as I read it, get rid of this line so I have a little more room. As I read it, it looks like we're going to end up dealing with distance, rate, and time, because it talks about how Brian and Kathy drove a total of 447 miles in 9 hours. And so those are total times. Okay, this is a total, well, totals at least. Total distance here, and here's a total time. Okay, so we're going to use those. So let's write those down here. Those are important things. We have some totals. So total, and we have a 447 miles, so that's a distance. And we have 9 hours, that's a time. So equals a distance, and this one equals a time. All right, so let's read further. Brian drove the first part of the trip and averaged 65 miles an hour. Kathy drove the remainder of the trip and averaged 45 miles an hour. So you're giving us rates, and what are they asking for? For what length of time did Brian drive? We want to know Brian's time. Okay, so let's do this. Let's go ahead and draw a little picture about what's going on here. So since we want to know Brian's time, let's go with Brian being the variables. And so let's do this. Let's say that here's our little picture. We've got 447 miles. That's the total distance from this point to this point. So that's a total distance. That's why I'm drawing a little line to show that's a total. And Brian drove a certain amount. Well, let's call Brian's distance D. Okay, so that's the distance he drove. How much did Kathy drive? Again, this is Brian here. And Kathy ended up driving, well, we want to use the same variable. So the total was 447. So let's do this. Let's go 447 minus D. Whenever you're given a total, you could do total minus an unknown, and that'll give you the other remaining distance. All right, so that's how we're going to set that one up. Time-wise, let's do the same sort of picture for time. Okay, here's the time, 9 hours. Well, Brian drove a certain amount. Let's say Brian drove, let's go with T hours. That's what we want to find. Let's call it T. Well, Kathy ended up driving a distance or a time of the total minus Brian's time. So that's what it's going to be, 9 minus T. So now we've got some different variables to plug in and some expressions for unknowns. So let's go ahead and write in two equations. We've got Brian's equation, and we're going to end up having Kathy's equation. And then we'll be able to have a system which we'll be able to solve, either using elimination or substitution. So here's Brian's equation. Distance equals rate, which Brian's rate, let's see, it's right up here. Brian drove the first part, averaged 65 miles an hour. So 65 times by T. All right, so that's Brian's equation. Kathy, well, Kathy, she had 447 minus D, we said. That was her distance. We're using the only one variable here, so we don't have to deal with two. And what was her rate? Let's go back up here. Kathy drove the remainder of the trip and averaged 45 miles an hour. So 45 times by her time. Well, go over here. Her time was 9 minus T, the total minus that part. Well, we can go ahead and solve now. The way we're going to solve, since we still have those two unknowns, is to substitute. Whenever I have D by itself, that's the best way to do it, I think. So I'm going to put that 65T in for that D right there. So let's go ahead and do that. 447 minus 65T. And over on this side, we got to multiply the 45 times by 9 and 45 times by T. So that makes 405 minus 45T. So we can go ahead and do some work now. Just move some terms around. So I'll go ahead and add this 65T to both sides. I'm going to add it, and 65T over here. And these will end up subtracting because they're opposite in sign, so I'm left with 20T. And I'll subtract that 405 from both sides. And when I do that, I'm left here with a 42. And so I go ahead and do the division there, divide by 20. And it doesn't go quite in there evenly, but I can go ahead and reduce that fraction a little bit. So I see that, let's see here, I've got to divide by 2. So divide each of those by 2, I end up with a 21 over 10. So that's going to end up being 2.1. So 2.1 hours, we'll say. Let's go ahead and put those units in there. 2.1 hours was the time it took, well, that Brian ended up driving. So there's the time, 2.1 hours. And that's all they wanted in that case. Well, let's take a look at the next problem here. Here we're dealing with another distance, rate, and time problem. It talks about a plane flying 900 miles with a tailwind. Okay, whenever they're dealing with a tailwind, that means there's two components to the wind, or to the rate. So let me go ahead and write down my equation real quick. Distance equals rate times time. And so we're going with a tailwind to start with. Okay, so there's tailwind, and then they'll probably talk about a headwind or maybe flying against the wind. So tail means with wind. All right, so let's go ahead and read further what it says. It says that the plane flew 900 miles with a tailwind. So 900 miles, that's a distance with a tailwind. Okay, it doesn't say anything about the wind speed or the rate of the wind speed. It doesn't say anything about the rate of the plane. So what we do know, though, is that the plane has some rate. So let's call R the rate of the plane. So R equals the plane's speed. And then we also have the W, we'll say, equals the wind speed. And we'll go ahead and write down, since he's going with the wind, R plus W is what we've got. So put that in some parentheses because that's an expression. Times by the time. Well, it took him 3 hours to go. So those are the two numbers that we were given there. It takes the same plane 5 hours, so 5 hours, to fly 900 miles, so the same distance, 900 miles, against that wind, against that same wind. So since it's going against, we're going to go with a minus. So against means that against wind means that we are going to subtract the wind. Tailwind with the wind means we're adding the wind. And so we can go ahead and solve now. Now when I do this, they want to know what the plane's speed is. There's a couple ways we can end up doing this. In this way, this problem here, I see that 3, I could get rid of this 3, and I can get rid of this 3 by dividing this entire equation by 3. But if you do that, you got to do the same thing to the other side. So what will happen here is the 3's will end up canceling, and I'm left with 3 into 900 ends up going 300 times, and it will equal R plus W. Over here, I can do the same thing because 5 goes into 900. Well, 5 goes into 9 4 times with, let's see here, we got, I'm sorry, 5 goes into 90 45 times evenly, and then we have that 0 that I can bring down, so 450. And so from there, I can go ahead and write down what's left over here. The 5's will end up canceling out. I've got an R minus W. And so let's check this real quick here. 5 into 9. Oh, I made an error there. Let me go ahead and fix that error real quick. Right here. Let's do that division again. 5 goes into the 9. We've got 1 time. 5 goes into, with 4 left over, and 5 goes into 48 times, and then with that 0. So 180 sounds a little better. And so we go ahead and add this together, and we can get those W's to end up canceling out. Well, in this one here, we have to add these two R's together. 1R and 1R end up making 2R. We added these two numbers together. We get a 0, an 8, and a 4. And then from there, all you have to do is one division problem. And divide by 2, and that gives us the rate of the plane. So 2 goes into 4 2 times. 2 goes into the 8. We have 2 goes into 4 2 times, and 2 goes into 8 4 times. And then bring down that 0. So 240. And these units would end up being miles per hour. So there it is, 240 miles an hour. So those are the types of problems you're going to end up seeing on this week's test. Good luck.